Hello, this is Peter from Educomondo and a warm welcome to our 5th STEAM project. This is the teacher edition called the RGB LED. Here we teach you, the teacher, how to bring science, technology, engineering, arts and math to your classroom in an exciting and engaging way. The level of this lesson is for absolute beginners in the field of STEAM. We call this level the Explorer level. The goals of today's lesson are: learn about a new component, the RGB LED, interact with the microcomputer through the serial monitor, learn new commands such as serial print and serial read string, practice the analog write and digital write commands, and play with while and if loops. Let's take a closer look at the RGB LED. By using the whiteboard, you can explain to your students that the RGB LED has 4 legs. The long leg is the negative or ground leg. The leg to the left of the long leg is the red color. The leg to the right of the long leg is the green color, and the outer leg is the blue color. Hand out the following components from the starter kit: the project board with the microcontroller and the breadboard, the RGB LED, 3 resistors of 220 ohm. We will also need 4 jumper cables with different colors, and I advise to use red, green and blue, as that will make it easier to build and maybe troubleshoot a project. Use the black wire to connect to the ground pin. And as always, the most important, the RGB color cardboard figurine. By showing this image, you can explain to your class how to build the project. You can keep this drawing projected on the whiteboard or keep it on your computer for their reference. Give your students a couple of minutes to build the project on their breadboards. By now, they have sufficient experience to do this fairly quickly. First, we push the RGB LED in the breadboard. We connect the red, green and blue legs to a resistor. In turn, the resistors are connected to the digital pins. For this project, we use the pins with the tilde symbol. Red goes to 6, green goes to 5, and blue goes to 3. The black wire goes to the ground pin on the microcontroller. After we have pushed the RGB cardboard over the LED, the finished project will look like this. Check with your students whether they have finished building and whether they are ready to connect their project board to the computer via the USB port. If all systems are clear, they can launch the Arduino IDE and open a new sketch to start programming. The first thing you probably notice is that for this and future lessons, we will be using the latest version of the Arduino IDE. This version offers additional functionalities. However, the older versions can still be used. To start, we create a space on top of the program and give our file a name. Lesson number 5, RGB LED. Next, we create another comment line because we know that we will need to declare some variables. And we do that in this space and not somewhere in the code. Because we have used pin numbers 3, 5 and 6 on the microcontroller, we are going to declare the following variables. int, red pin equals 6, green pin is set to 5, and blue pin we set to 3. We will probably also need some delay by color, so it is safe to already declare those as a variable. int dt green equals 50, int dt blue equals 50, and int dt red equals 50. We set the value initially at 50, but we will be able to play around with these values later on. We may also need a general delay, so it's good practice to already declare these now. int dt equals 100. In the void setup, we activate our pins by using the pin mode command. Pin mode, in between brackets, red pin, comma, output. Pin mode, green pin, output. And pin mode, blue pin, output. Remind your class that they have to watch the color of the commands change. If it doesn't change, they have written the command incorrectly. And of course, each line has to end with a semicolon. Next we go to our void loop section. From what we have learned in lesson 4 on traffic lights, we can use the following commands to make the LED colors go on and off. Digital write, in between brackets, green pin, comma, high. Delay dt green, digital write green pin low, and we do the same for the other colors blue and red. Let us upload the program and check whether it works. You can clearly see the colors changing from red to green to blue and back again, each time with a delay of 50 milliseconds. Now that we know that our project works, it is time to teach our class something new. We are going to teach about the serial monitor. The serial monitor is an Arduino tool that lets you send and receive text messages to your microcontroller. The first step is to set up this monitor in the void setup space by typing the command serial.begin and in between brackets 9600 ending with a semicolon. The 9600 is the baud rate. The baud rate is the speed in bits per second by which we send data to the monitor. It is named after Monsieur Émile Baudot, and its symbol is BD. In the void loop section, we type the command serial.print in between brackets hello world. We can mark all of our previous code as a comment simply by typing the / and star at the beginning and ending with a */. You have seen that the color of the text changes. At this moment, all that is between the slash and the asterisk is considered as a comment and will be ignored by the program. Let your students change their programming in their IDE. And once they are finished, show them that they can open the serial monitor by clicking on the small magnifier symbol in the right upper corner. The serial monitor pops up and you can position it to a place where it doesn't cover your IDE. Let your students run the program and see what happens. It doesn't look very nice, does it? Let's go back to our programming and change the command to serial.println hello world, and adding the ln will put a break between the lines. To slow down the printing, you can also add a delay in the loop. Delay in between brackets dt. Ask your students to make these changes and run the program again. It will look much better. Now we know the basics to send information from the microcontroller to the serial monitor. But how can we send information from the monitor to the microcontroller? Getting information from the serial monitor is a three-step process. We ask a question, we wait for a response, and we read the input. To do that, we will introduce some new command lines. But first, let us clean up our IDE and delete the lines that we don't need anymore. To ask for information, we have to send a question to the serial monitor. We use the print command that we learned earlier in this lesson. Serial.println, and in between brackets and hyphens, what color do you want? Then we have to wait for a reply. And here we introduce a while loop. While serial.available equals 0 and the curly brackets beginning and ending with curly brackets. Basically, this command tells the microcomputer to do nothing while waiting for an input from the monitor. We use double equal signs to indicate that the status is equal to 0. A single equal sign would set a value to 0. You will have to stress to your students that this is an important difference. In the line above, we can write some input. Since this input is a variable, we have to declare this variable. Let's call it color input. So far in our lessons, the variables were integer numbers. Color input is not a number, but a word. In the Arduino IDE, we call this a string. String color input and ending with semicolon. We are now ready to read from the serial monitor. We go back to the loop section and add color input equals serial.readString. And don't forget to open and close the brackets, ending again with a semicolon. Now that we have read the user input, we have to interpret it. This interpretation is done through a number of if statements. If the color input that we receive from the monitor equals red, what do? We write digital write red pin high, and we set the green pin to low and the blue pin also to low. Ask your students to upload the program and let them type red as input. They all should report back to you that the red part of the RGB LED is on. You can add as many if statements if you like, so the same would apply for blue or green. The great thing about the RGB LED is that you can mix the colors red, green and blue to make new colors. Have a look at this color wheel. We can make colors like yellow, orange, violet by mixing the right amount of red, green and blue. On this chart, we can actually see how much is needed from each RGB color. This is where the analog write comes in again, and why we selected the pins with the tilde. Let us first create the color violet. Copy the numbers from the wheel. If color input equals violet, then we have to write an analog write to the red pin with a value of 128. We do not need any green color, so the green pin is set to 0, but we need a lot of blue, so we write blue pin 255. Let us do one more, orange. If the color input is orange, then we have to do an analog write to the red pin of 255, and we have to mix it with green, so the green pin we set at 128. We don't need any blue, so the analog write is just set at 0. We can upload the program and check whether all works. We type violet as the user input, and yes, we can see that the RGB LED gives a purple light. When we type orange, we can now see the color changing into an orange light. Congratulations! If it also works for your class, they have done a great job. If not, do not panic. Do some logical fault finding. Did you end all commands with a semicolon? Did you type all commands correctly? Check the color of the commands. Did you put the wires in the right pins? Did you declare the right pin number as a variable? Are all connections on the breadboard firm? Is the LED not broken? Troubleshooting is a great learning moment for your students. Tell them that this is not a failure. They will learn while collaborating together and thinking logically, step by step, through their program. This concludes our 5th project, the RGB color card. Time to repeat with your class what they have learned. They learned about the new component, the RGB LED. They interacted with the microcomputer through the serial monitor. They learned new commands such as serial print and serial read string. They practiced the analog write and digital write commands. And they used and played the while and if loops. Because we experimented with mixing colors, here are some ideas for an assignment. How can you make yellow, rose, and bright green with an RGB LED? How do you get white with an RGB LED? And how do you obtain black with an RGB LED? Next to RGB, there is also something called CMYK, cyan, magenta, yellow, and black. And what is the difference with RGB? And there are also other colors like infrared or ultraviolet. Can you find out and explain to your class what these are? Well, have fun with the assignment, and I'm looking forward to start with lesson number 6. In that lesson, we are going to work with multiple LEDs and multiple variables. The lesson is called the battery billboard. Bye bye.